We're going to look at these first two examples. We've actually done this before, right? We've solved problems where you have coordinates and then you're having to come up with all of the different trig functions. So ultimately what we're going to be doing, let's focus our attention just on this one. So we're going to be finding the sine of theta and the cosine of theta and the tangent of theta and then its reciprocals. We've done this with coordinates already before. We're on page 13, Tochi, bottom of the page, okay? All right. The main reason why we have to learn and remember these different ratios is because of this type of problem right here. So that's why we're starting with one of this type. Remember, we decided or determined that the sine ratio, for the sine, we are looking at y over r. And for the cosine ratio, we are looking at x over r. And the tangent ratio, we are looking at y over x. Now, what gets confusing is that we've just been dealing with unit circle, and we still are. If we're dealing with unit circle, we know our radius is just 1. But if we're given other points, our radius is not just equal to 1. And so we have to still consider the r part of this too. So I want you to think about this particular example. We cannot draw a triangle here. If I try to draw a triangle, think about what this is saying. This is saying we're going right 7 and we're not going up or down. So there's no triangle to be made here. The triangle would basically collapse onto the axis, right? But we can think about what the radius would be. What distance are we going out from the origin to get to that point? We're going out 7, so our radius is 7. So to come up with the ratios, we're going to do sine is y over r. So what would that give us? Juan, what would that be? Careful. Give me the numbers. For sine, we're doing y over r. Good. 0 over 7, which is just equal to 0. Now, for our cosecant, we're going to flip that, and we would get 7 over 0. Then, you're right, that is undefined. Right? Okay. Cosine, for our cosine value, remember our ratio is x over r. So, Sophia, what would that be? I'm sorry?
What was the question?
For cosine. So the ratio for cosine, so x over r. So what's our x?
Oh, for this.
7 over our r value, which is, what's our r value? 7. So we get 7 over 7. So yeah, so we just get 1 for our answer. Now, if we're finding the secant of that and we flip that, we're still just going to get 1. So that's pretty easy. All right, tangent of theta, Luca?
It would be 0 over 7.
Great, which is equal to, we know is equal to 0. And so for our cotangent, that would also be undefined. Okay, so this is kind of a special case because it's like on the axes. It's one of our quadrantals. So that's why I wanted to show you an example of that type.
Was it that when so I'm kind of confused as to why the radius is 7 for this. But how do we know that?
Because we're going out, think about where that point is.
But do we know that that's like not like it could be like if the radius could be here, it could be anywhere like shorter, right?
But we're told we're on the coordinate plane and we're going out. Sorry, let me change colors here. We're going out 7 and we're not going up or down. So we're going out that distance of 7 there. So that distance or that radius would have to be 7.
So for the other ones, what do you guys do?
The other ones we've got to do Pythagorean theorem. Yep. Okay. Hurry, yes. Tochi, did I answer your question or did you have a question too?
Yeah, I had a question too. I'm wondering,
Cosine, the ratio for cosine is x over r. And our x coordinate is this one. It's the 7 over r, which is 7. So we would get 1. Okay? All right, so let's look. That was kind of, like I said, that was kind of a special case. This one is an actual point. So we could draw a triangle for that. We're not going to because In my opinion, it's a lot faster and easier to do this. So we're bottom right at that -3, -4. This is a lot faster and easier if we just think about what our x value is, our y value is, and you should be able to tell me the r right away because that's a triple. 5, right? There you go. If it weren't a triple, then we would do Pythagorean theorem. X squared plus y squared equals r squared, and we would figure out what r is equal to. But I gave you a nice easy one. Sine, cosine, tangent. And let's look at reciprocals also. Okay, now let's, yeah. Okay, so our sine value, Andrew, what would it be?
-4/5.
-4/5, sounds good. That means our cosecant is -5/4. Christopher, what about our cosine? -3/5, because we know it's x/r, so this is going to be -5/3. And then for tangent, we know we're doing y/x. So Drew, what do we get?
-4/3.
Good, -4/3, but then we want to divide out, we want to simplify those negatives, so really it's positive, right? Good, and then our cotangent would be 3/4. Okay, so that's kind of review, but you're going to see some examples in the homework where you have to do that, so I wanted to share that with you. Okay, the next page, I want to share just a visual. You've already seen this, I've already talked to you about this, but I want you to add something down on the bottom of the page, down below that. I think for some of us who are visual learners, it helps us to see. I want you to include a little quadrants for each of the, I want you to think about where sine values are always positive, where cosine values are positive, and where tangent values are positive. So draw just a little coordinate plane and label a sine and a cosine and a tangent. And then I'm going to ask you to do some kind of some shading there. Thank you, Avery. Okay. Sine values are positive. Sine values correspond to our y's. So where are the y values positive on a coordinate plane? In which two quadrants? A and S are 1 and 2, exactly. So visually that means sine values are positive up there, right? What about cosine values? 1 and 4. Okay, I couldn't tell if you had, I heard the one part, I couldn't tell if you had said 3 or 4, so I wanted to make sure. Yeah, so 1 and 4. So for cosine values, our positive cosine values are there, right? Now, tangent's a little bit different. Think about tangent. This is why I think it's helpful to kind of visualize this. So for sine, two quadrants are next to each other. For cosine, they're next to each other. For tangent, think about it. It's where the x and the y values have the same sign. So it looks weird, but it's kind of more checkerboard. They're actually diagonal from each other, right? So where I have shaded in quadrants 1 and 3, that's where tangent values are positive. It means tangent values are negative in quadrants 2 and 4. All right, by the way, if sine values are positive, if you think it's going to be helpful, you may want to put a little note or reminder. That means cosecant values would be positive in that same place, right? And secant values would be in the same place here, and cotangent values would be in the same place there.
Do we need to include that on this thing too? Or?
No. I just was looking for your sines, cosines, and tangents. But on down the road, it might be helpful to remember that. If you can remember where your sine and your cosine and your tangent are positive, the reciprocal ones, they just carry the same signs as the originals, so that makes it pretty straightforward and easy. Okay?
What would that mean for, are those coterminal, like?
These are the reciprocals
Yeah.
of
Have we used coterminal?
coterminal angles. Coterminal angles we add or subtract 360 or 2 pi
Yeah.
in order to find coterminal angles. Is that what you're thinking about?
I'm thinking of the one that's like, I think it is this.
I don't know. Okay, if you think about it, let me know. Let me know, and I'll kind of talk you through. All right. These problems are very similar to what we did with the coordinates, so that's why we kind of did that segue in to this. But they are a little bit different. There's a little bit different thought process, because we actually kind of want to actually draw these out in the coordinate plane and then think more SOHCAHTOA rather than X's and Y's and R's. You can still use X's and Y's and R's, but you can also use SOHCAHTOA for these. So notice what is going to happen here. For this type of problem, they're going to give you a trig function. They're going to give you the ratio. They're also going to tell you the quadrant, or they're going to tell you information so that you can figure out which quadrant you're in. And then you've got to figure out all of the other trig functions. So the nice thing about this, people were freaking out yesterday. They were like, we have to find all 6? No, actually you don't, because you're given one. You're given that the cosine of lambda, that's a lambda, by the way, not an upside down y. That's a Greek letter, that's a lambda. So we're told that the cosine value is 5/6. That means we know that secant value is 6/5. So we actually only have to find 4.
Just do Pythagorean theorem to find the other.
We just have to do Pythagorean theorem, label that other side, boom, we're done, right? So let's do Pythagorean theorem. So 36 minus 25 equals y squared. So we get the square root of 11. Now you do have to be conscious and be careful. We're in quadrant 4, right? And we're labeling this side. That side's going down. So we need to make sure we remember to include that negative. Remember, hypotenuse or radius is always going to be positive. So any values, the sides of your triangle might be negative, but you got to think about whether it should be positive or negative. In this case, the positive 5, but then that negative square root of 11. Okay, so now we can do our sine and our tangent. So what would our sine value be? There you go, negative square root of 11/6. We got to flip it for our cosecant, and that means we're going to have to rationalize also. So we're going to have negative 6 root 11/11. All right, and then what about our tangent? What's our tangent going to be? Tochi, what's our tangent going to be? SOHCAHTOA. There you go, negative square root of 11/5. And so now let's flip that and let's rationalize. And we're going to get that. Okay, all right. Now, guys, I had the triangle drawn in for you already for this first one. I want to show you and remind you how you draw in the triangle if you're not given the triangle and you need to draw it in. So we're in quadrant 2, right? So to draw the triangle correctly so that it fits in whatever quadrant, not necessarily just in quadrant 2, but go ahead and put a point in that quadrant where you want to, just put a point out there. And then from that point, you want to draw to the origin, and then go back to that point and drop to your x-axis, and that'll drop your perpendicular. So from point to the origin, from point to the x-axis.
You're going to draw a point, like...
Wherever. Yep. We don't have to draw it to scale, per se. Your delta math that you're going to do for homework, it is asking you to actually show where coordinates would be, so you're going to need to be a little more precise on that. But to draw these, you don't need to be real precise. All right, so our angle beta is down here, right? Closest to the origin and just above the x-axis. And we want to label, this is given that we're told that the tangent is negative 5/12. So tangent we know is opposite over adjacent. Now, let's talk about this for a second. This is a really important concept here. Which one of those numbers should be negative, the 5 or the 12? The 12 should have the negative sign attached to it. It looks like the 5 should have it with the way this is written up here. But the 5 is going up, right? The 12 is going to the left in the negative direction, so the 12 needs to have that negative. So that's a really important concept. You got to be careful about where you're labeling. All right, this one's a little bit easier because it's a triple, so the hypotenuse or the radius is, what is it? Okay, 13. Okay, I misunderstood. Yes, you did have that right. Good. Okay. We were given our tangent already. And so that means we already know our cotangent. So now we just have to do sine, cosine, and its reciprocal. So sine, what's that going to be, Ava? Our sine of beta. What's the ratio going to be? Think SOHCAHTOA. There you go, 5 over 13 for our sine. That means our cosecant is 13 over 5. And what about our cosine? Brock? Think SOHCAHTOA.
Is it negative 12?
Negative 12 over
Over
13. There you go. You got it. So negative 12 over 13 for our cosine value. That means our secant is 13 over negative 12. Beautiful. Guys, this is just a reminder. You've seen this already. You know these, but you need to kind of think about different ways of getting this memorized. We know our sine value is considered our y and our cosine is considered our x. So I want you thinking sines and cosines there also, right? This is x over y. So tangent is sine of theta over cosine of theta. Cotangent of theta is cosine of theta over sine over theta. We're going to use that a lot over the next few weeks. So,
I have a question.
yes.
This example where we drew the 5, 12, 13.
Okay.